at chapter 6, exponents and radicals today. And the first thing that we should do is open up our packet and look at this first page here, which starts our class notes on exponent rules. So the first thing that it's asking us is, what is a power? So a power is referring to an exponential expression that's used for whenever you have a big number at the bottom that we call a base and a small number at the top that we call an exponent, we would call this a power. So I know that you have probably seen exponents in the past, but here's a little refresher. So 3 to the 4th power is how I would say that. If this was like, if it was squared, you might hear me say 3 squared. That would mean 3 to the 2nd power. If I said cubed, maybe that was like 4 to the 3rd power. But in this case, you would hear me say 3 to the 4th power. That means the base is 3, the exponent is 4. What this actually means is that the base number is being multiplied by itself the exponent amount of times. It is different than 3 times 4, though. I need everyone to understand that. 3 to the 4th power is 3 times 3 times 3 times 3, which ends up equaling 81. 3 times 4 is obviously just 12. It's not the same thing. So let's do some notes. What is a base? So the base is the number that gets multiplied. Whereas the exponent is the number that tells you how many times to multiply the base. For example, if I have something like this, 5 squared, that means 5 to the 2nd power. That does not mean you take 5 and you multiply it by 2. That means you take 5 and you multiply it by itself so that there are 2 5s there. This is the same thing as 5 times 5, which then you can simplify to be 25. So the base number is the number that's being multiplied. The exponent, the little number that's above it, is going to be how many times you multiply the base number by itself. What we can do is take expressions and put them into exponential form, or we can take exponential form expressions and expand them into long mathematical expressions. In letter A, we're converting this problem, which is -2 times -2 times -2 times -2, and we're going to rewrite it so it's not all of those things. We can take this and we can basically bring it into just one of the -2's and raise it to a certain power. So since the -2 is what's being multiplied, that will be the base. So the base of this is going to be -2, and the exponent is how many times it's being multiplied. What number would I need for my exponent? 4. So this would be -2 to the 4th power. Now there is something weird about negatives. When there are negative bases, you actually need parentheses around the -2, and I'll explain that in further sections. But anytime you have a negative base, you're going to want to put parentheses around it so that I know you're multiplying -2 times -2 times -2 times -2, and not just taking a negative of whatever the answer is. Now these problems are asking us just to convert them, not necessarily get the final answer in the end. So we're going to then move on to letter B, which is asking us to go from exponential form to expanded form. 5 to the 5th power, if I was to expand this out, I know it's kind of silly to answer this out loud because it's a lot of the same thing, but what would I do? Aiden?
5 times 5 times 5 times 5 times 5.
Yep. So literally 5 times. And we could get the numerical answer for this, putting this into our calculator, hitting enter, but that's not the goal of this. It's just to expand it or put it into exponential form. What would I write letter C as? What would this be in exponential form?
4 to the 3rd.
Perfect. 4 to the 3rd power. And then letter D, what would I do to expand that?
3 times 3 times 4.
Perfect. Okay, so pretty simple. So that's just a recap on the way that exponents work. So if we flip this to the next page, we're going to be learning 2 rules today. We're actually going to be kind of going around a little bit. We're going to learn rule 1, and we're also going to learn rule 6, and then we're going to practice. So rule 1 is that if you multiply powers with the same base, you actually add the exponents. me show you how that works and why that comes about. So if I gave you this problem here, 7 to the 4th power times 7 to the 5th power. They have the same base. The bases are both 7s. 7 to the 4th power is really 7 times 7 times 7 times 7, right? Times 7 to the 5th power is really 7 times 7 times 7 times 7 times 7. Altogether, how many 7s are there? 9. I can also get that 9 without doing the expansion and getting all the 7s. I can take a look at the exponents, the 4 and the 5, and I can do what with them? Add. I can take the 5, the 4, add them, and then this turns into 7 to the 9th power without having to expand it all out and then count them all up. So it's super simple. It only works when the bases are the same. The bases have to be the same number. So that's why it works, because the 7s were the base number and they are the same. In example B, the base number is a variable, but those variables are the same. So because they're the same, that means they're the same base, the same number. I can take the exponents and I can add them. This is going to end up being a to the power of what?
8.
Yes. 6 plus 2 is 8, so this is going to be 8a to the 8th power. And just because this is our second example ever, I'm just going to show you a to the 6th power is a times a times a times a times a. We're going to need one more. And a squared is a times a. There's 8 a's altogether. That's where this comes from. But no need to do that if you can just use these rules. So we're going to be practicing problems that allow us to use these rules. It's just going to be different. It's kind of fun, I actually think. The last rule we're going to learn today is actually Rule 6. You have to keep flipping the pages in your packet to find this. So bear with me. Flip through until you find Rule 6. Like, you're going to pass a bunch of stuff. Keep going. You're going to see the top of the page says Rule 5, and under it says Rule 6. It's the 4th page in. So it's on the back of one of the pages. Maybe that's where you're getting lost. So Rule 6 says a power with an exponent of 0. So when evaluating a power with an exponent of 0, this is a weird thing that happens. The answer will be equal to 1. I know you're used to when you multiply by 0, the answer is 0. But with exponents, when you ever take anything and you raise it to the power of 0, the actual answer is going to be 1. I'm not going to go into detail about why, but I can show you that it does work. If I pull up my calculator here, if I take it was 209, right? 209, raise it to the power of 0, the answer is 1. If I take anything and raise it to the power of 0, it's going to be 1. So if I take a decimal, 0.2, to the power of 0, it equals 1. If I take a fraction, like 1/4, raise it to the power of 0, it equals 1.
Why would it not be 0?
So it's not 0 because when you have a power, it's like the opposite of squaring something. It takes it and turns it into a fraction. But when you have it raised to the power of 0, it ends up just equaling 1 because it cancels out the multiplication and division. So it's confusing because exponents, if you're increasing the exponent, it's multiplying. If you decrease the exponent, it's dividing. And the opposite of multiplying and dividing cancels each other out, which equals 1. That's just kind of my quick explanation without going too much into detail. But great question. I appreciate it. The only other thing that's not going to make it equal to 1 is if it's a negative. So take a look at this. Negative 3 to the power of 0. It's not going to be positive 1. The answer will be negative 1. So if you ever have a negative, it'll change the answer to negative 1. It works for variables as well. So in this case, the base is not a number. The base is a variable. The answer is still going to be equal to 1. Anytime you see anything raised to the power of 0, it's just equal to 1. It's just it. We should also write another example here, though, that anything like a negative 3 raised to the power of 0 will not equal positive 1. But it will equal negative 1. That's important to note. Okay, that's all the notes for today. Now we're going to move on to some practice. The easiest way to get to the practice problems that we're going to is closing your book, opening it back up, and it's the second page. So the page we're looking for looks like this. Or just go back to the front until you see this. It's the second page of the packet. So we are going to be simplifying these expressions using the two rules we just learned. The two rules we just learned are if you have the same base and you're multiplying those numbers, you add the exponents to simplify. And also, anything raised to the power of 0 will equal 1. So in number 1, we have here 4 times n squared. Something to note is whenever we have no operation in between numbers or variables, we should know at this point it means multiply. So everything here is being multiplied. Even in number 4, there's one random multiplication symbol here, but that doesn't mean that these things aren't being multiplied as well. They just have one random multiplication symbol, I don't know why, but everything is being multiplied in all of these questions. So when we're simplifying exponential expressions, first thing we should look for is the plain constant numbers. That means like this number here. This is just a 4. Now, if we had another number in this problem, I could multiply 4 times 3, or 4 times 2, or 4 times 7. Any numbers that are in the expression can be multiplied together. If they had the same base, I could use exponential rules, and I could take the exponents and add them to simplify. But in this case, the 4 has nothing to multiply with it, so when I go to simplify my final answer is just going to start with 4. There's nothing I can do with that. But I can simplify n times n squared. Whenever you have a plain variable, there is an invisible exponent there. This is n to the first power, but we don't ever have to write that because it's kind of useless. Anytime you have any x or a variable that just has a plain thing with no exponent, there is an invisible exponent of 1 there, saying that there is one of these. But up to this point, we didn't need to see that because this is the first time you're really being exposed to exponential rules. So when I simplify n to the first power times n to the second power, you take the two exponents and you add them, and this will turn into n to what power? 3. So this is going to be n to the third power. That's your final answer. There's nothing you can do with that. That's simplified. You will know it's simplified if you only see one type of base and you don't see multiple n's anymore, or multiple x's, or multiple whatever else is in the problem. Number 2 is very similar, almost identical, except this is 4 times n to the first power times n to the third power. When I go to simplify this, the only thing I can combine together would be n to the first power times n to the third power. This final answer will be 4 times n to the fourth power, since n to the first times n to the third will be n to the fourth, because I add the exponents, and 1 plus 3 is 4. I feel like there's a lot of 4s in these first 4 examples, and then it's going to stop doing that. It's just a weird coincidence. But number 3, there's still a lot of 4s. X to the fourth power times 4x. Well, I always like to put my plain numbers first. So this 4 here, I'm going to bring out in the front. There's nothing to multiply with it, so it's just 4. And I can combine, even though they're not right next to each other, I can combine x to the fourth power with that x there. You just have to know that x is x to the first power. So I add x to the fourth, x to the first, and that's going to become x to the fifth power. That's simplified. Okay, everyone with me? Okay, next one. Here's the first example that we have multiple numbers we can actually multiply like we normally would. This says, and you don't have to show this part, I'm just showing you. This is really 4 times n to the 0 times 4 times n to the 0. When I have multiplication, I still follow the same exact steps I normally would with multiplication, meaning I can multiply 4 times 4, I get 16. But then what happens with the m's? Aiden?
I think it would become 2m, but isn't everything gonna end up turning to 1?
Yes. The reason why it's going to turn into 1 is because anything raised to the power of 0 equals 1. So m to the power of 0 equals 1, m to the power of 0 equals 1. If you wanted to simplify, you could do 0 plus 0, which is 0. Altogether, you're going to get 1s. And 16 times 1 times 1 is just 16. So it's almost as if these cancel out with exponents. Anytime you have m to the 0, you literally can just cross it off. It just equals 1. When you're multiplying, 1 it never changes the value of a number in multiplication. So you don't have to worry about it. You almost can just cross it off because it will just go away. Yeah. Yes. But only the thing attached to the 0 will go away. Like this 4 does not go away because the only thing attached to the exponent of 0 is the m underneath. We're going to do one more together, and I'm going to have you guys work on the rest with your group members at your tables. So number 5, things are starting to get a little bit more interesting. This is 2 times y times x squared times x to the 4th times y to the 3rd. First thing, looking at the plain numbers, the coefficient numbers I like to call them, which are the numbers in the front. I only have 1, 2. There's nothing to multiply with that, so I know the answer is going to be 2 here to start. And then I have x's and y's. And I want to start training you guys into understanding that in the future, your math teachers are going to be specific in how they want you to answer things. And we like to see things in alphabetical order when we have multiple variables. So even though the next variable I see next to the 2 is a y, I'm going to start with the x's because x comes before y. So the x's means I'm going to simplify x squared times x to the 4th, and that turns into x to the what? Yes, x to the 6th power, since 2 plus 4 is 6. And then moving on to the y's. I have y to the 1st power here and y to the 3rd power there. I can combine the y's together to be y to the what? 4. Exactly. So this is the answer. It's not wrong if you have it in a different order. So if you had 2y to the 4th times x to the 6th, it's still right. I just want to start training you to try and get into the habit of putting your answers in alphabetical order for the future. Okay? What I want you guys to do is go ahead and try the rest of the page. We'll go over the answers in, I don't know, probably like 10 minutes or so, and then we'll call it a day.